So, I'm not given a function here that represents this particular situation. I am going to have to use my old school geometry formulas to do this. What do you see in this picture? Triangle. You can see a couple different things. You can see a triangle here. And what about over here? A triangle and a rectangle or a trapezoid. Okay? So say you don't remember the trapezoid formula, you can always break it down into another triangle and a rectangle. Okay? Does anybody remember the trapezoid formula? It's 1/2. It is similar to triangle. It's B1 plus B2. There's something that's right here.
What's the difference? Oh, height. What's the difference between a trapezium and a trapezoid?
Same thing.
Oh, it's a reference.
Yeah, the trapezium is the trapezoid. Yep. So good review right there, for those who forgot. Okay? But again, you can always break it down into two, another triangle and a rectangle. What's the area of a triangle again?
4.5.
Okay? So to find from 0 to 10, we have to basically find the area from here and the area here. So, 1/2. What's my base? 5. What's my height? -6. Okay? And when I take half of 5 times -6, what does that give me? -15. Now, if for some reason you just put 6, you would get positive 15. But because the triangle is below the x-axis, the area should be what? Negative. And since you use -6, it kind of already took care of that.
So we got negative area.
Mm-hmm.
I know.
Okay. Well, I'm recording, so you can watch that. All right. So over here, the trapezoid. What's the height? Is what? 6. What's the base? What's one of the bases? 5. And the other base is 3. Mm-hmm. Because this is 3 units here. 5 units down there. So what's 1/2 of 6 times 5 plus 3? 24. So now that you have your two areas, you can subtract 15 from 24, or you could add 24 to -15. Either way, you get your answer of 9. Okay? Now, if they actually gave us a function to represent this, then we would have to split it up. So we would find the area from 0 to 5 and the area from 5 to 10. Okay? So, alright, so the very first one, okay, is basically your constant rule. Okay, so the constant rule still applies here. Alright, if you have a number and then a number in front of a function like 3x squared, you can pull the 3 out, you take the integral of x squared, and then you're going to evaluate it from a to b. And you'll see what I mean in just a second. So the constant rule still applies. 2 is like the sum and difference rule from before, okay? If you have two functions that are being added together, well, it's basically the first function from a to b plus the second function from a to b. So that still applies here. 3 is an interesting one, because if you notice, the integral from a to b of f of x dx is equal to the negative integral from b to a of f of x. So basically, whatever this equals, if the bounds get flipped, then whatever this equals becomes negative. Okay? For number 4 was what we just went over. Okay? If it crosses the x-axis, then you have to split it up. And then 5, if it's being evaluated to the same point, there's no area underneath the curve because it's just at that point. So that's why it equals 0. Okay? So here are a few more properties that you need to make sure that you are aware of. The first 2 are the ones we've already dealt with. The fourth one was the split. and then 3 you flip them, or you make it negative, and the last one equals 0. Okay? So let's look at a few examples. Here are your directions, here are 2 examples. Starting very general at first, and then we'll get to a little more specific. Probably won't get to it today, so I'll have to save it till Monday.